Hello, everyone, and welcome to Precalculus. This is section 10.3 on ellipses. Ellipses are formed by the intersection of a plane with a cone, but at an angle, like that. If you went straight across, then the intersection would be a circle, but this is going to form an elliptical shape. We haven't studied them in algebra because they are not functions. But the way we're going to talk about them today is the fact that an ellipse is the set of all points in a plane, the sum of whose distances from two distinct fixed points is constant. So what that means is if I have two fixed points, they're going to be called the foci. If I have these two fixed points and then I have distance A and distance B, the sum of A plus B could be drawn differently. So maybe A is a little longer, but then B has to get a little shorter. A could be really long, but then B would have to be really short. If you drew all of those points that those two distances made, you would get an ellipse. So the parts of ellipse, the longer section of the ellipse is going to be called the major axis, and the shorter one is the minor axis. This is the center, and the 2 points at the ends of the major axis are called the vertices, singular vertex, plural vertices. Similarly, there's going to be two focus points somewhere inside the ellipse, and when they are plural, they are foci or foci. It can be pronounced either way. So the equation for ellipse, it looks, again, like last time, like it's complicated, but they're just showing you the same equation with variation based on whether or not the ellipse is sideways or up and down. And the only thing they changed was A. So pretty much what I just think is A is the longer one. So if you see A is under the X, then you know that the ellipse is going to be going sideways. But honestly, I don't really think so much about that. I just know that the length in the X direction goes under the X and the length in the Y direction goes under the Y. And whether you call them A or B isn't really going to matter. You do need this formula to find where the foci are, A squared minus B squared. But even if you haven't specifically labeled them A and B, you're going to pick the larger one minus the smaller one. So again, the actual label A and B doesn't matter so much. But we'll do a bunch of examples and you'll see. So this equation doesn't look anywhere near as complicated. That's because we're going to start with one with the center right at 0, 0. But this is what it would look like if I actually wrote that 0, 0 in. And like I said, I don't worry much about the A and the B. I just think to myself, this is 5 squared. It's under the X, so I'm moving 5 in the X direction away from the center. This is 2 squared. This is under the Y, so it tells me how much to move in the Y direction. I didn't even use A and B at all. Those are the only 4 points I require. Obviously, if you got another one in the middle, you could maybe make a slightly better shape, but we're just going to go with the 2 vertices. And if you want, you can call these ones co-vertices. But people often just refer to the vertices as the ones on the major axis. So they ask us to find the center, which for this one is 0, 0. The vertices, which are, you may write them as plus or minus 5, comma 0, or you can actually separate them. 5, 0, negative 5, 0. And the foci. So those are those 2 special points that would make the ellipse if you found this sum. So D1 plus D2, if you added those 2 up in any direction, any point, if I did this one and this one, if I did this point over here, this one and this one, every single time those 2 distances would be exactly the same, which honestly is really cool. But the equation that we're going to use to find the foci, so C is the length from the center to the foci. And it is always on the major axis. So again, you can figure out what A and B are, or you can just say, well, A is the bigger one, right? So 25 minus 4. So c squared is 21. C is equal to the square root of 21 in both directions. So this point right here must be negative square root of 21, comma 0. And then that foci must be positive square root of 21, comma 0. But again, you're welcome to write it as plus or minus the square root of 21. You don't have to write them separately. And that's an ellipse. Let's do another one. I'm going to make it just a little bit harder by having a center. So remember to put the y with the y. So even though this one is seen first, it's going to go here. And of course, it's opposite, just like always. I love math. It's very consistent. Negative 3, 2 is right there. So this number is 4 squared, and it's under the y. So I'm going to move 4 in the y direction and 4 down in the y direction. Because this is bigger, I do know that it's going to be a elongated ellipse on the y-axis instead of horizontally. This number is a little harder to figure out what the square root is. It's because it doesn't have a perfect square. But this is the square root of 5 squared. So how am I going to plot that? Well, the square root of 4 is 2, and the square root of 9, which is a lot bigger, is 3. So it's pretty close to 2. So as long as you just kind of go a little more than 2 in each direction, you don't even have to get out your calculator. You can just say square root of 5 must be approximately 2.1 or 2, whatever you want. And now you can draw it. So I still need to find c. Remember that c squared is equal to a squared minus b squared. It doesn't matter which one's a and b, as long as you just do the bigger minus the smaller. So c squared is equal to 11. C is equal to plus or minus the square root of 11. So you are going to have to work a little harder than last time because the center isn't at 0, 0 this time. So remember that the foci are going to fall on the major axis, and it's going to move square root of 11 away from the center. So again, like last time, you just have to estimate it. The square root of 9 is 3, so maybe this is 3.2 or 3.3. The bottom line is you're not going to be able to graph 3.2 differently than 3.3 anyway. So 1, 2, 3, something like that is fine. But you do have to be able to label that point. So as long as you have the picture, it's easy. It's negative 3, comma, and then we started at 2 plus the square root of 11. And then this point is negative 3, comma, 2 minus the square root of 11. Really, the only people that get this wrong are the people that don't make the sketch. And then because they don't have a sketch, they can't remember which one the square root of 11 gets added to. So if you add the square root of 11 to the negative 3 instead of to the 2 because you haven't made a sketch, don't expect partial credit from me. You have to be able to get that right. All right, I think we found everything we needed. We got our center. I guess I didn't actually label it, but our center is at negative 3, 2. We have our vertices are at negative 3, 8, and negative 3, negative 2. And then our foci. Number 2, find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1, and a major axis length of 6. And the key is the same that it was last time. Make a sketch. No sketch, and wrong answer, no partial credit. So the foci is at 0, 1, and 4, 1. And because the foci are evenly centered around the center, I do now know that the center is going to be at 2, 1. So I can actually start to write my equation already. X minus 2 squared plus y minus 1 squared is equal to 1. Look at that. I've already got quite a bit of my equation. And then it said that the major axis length is 6. Now, because the foci are always on the major axis, I know that this is going in the x or horizontal direction, and it has a length of 3. So from my center, 1, 2, 3. From my center, 1, 2, 3. Now, I don't have to draw it perfectly, but now I know it looks like this. So because this length right here is 3, it's in the x direction, so I put 3 squared, which is 9, underneath the x. To get how much it moves in the y direction, which we're going to just call b, just to have a letter associated with it, Then I'm going to do C, which is 2, and A, which is 3, and my equation is C squared is equal to A squared minus B squared. So 4 is equal to 9 minus B squared. Negative 5 is equal to negative B squared. B squared is equal to 5. I actually don't need to finish this because for the equation, what they want is B squared. So even though B is the square root of 5, you're still going to put 5 in your equation. Number 3. Sketch, are you ready? This is where it gets hard. Sketch the ellipse given by x squared plus 4y squared plus 6x minus 8y plus 9. Okay, pay attention. So we're going to put all of our x's together. X squared plus 6x, and then I personally am going to write blank. And then I'm going to put my y's together. 4y squared plus minus 8y plus blank. And then I'm going to put the number on the other side. I don't need that with this. So if you didn't understand completing the square before, you need to make sure you get it now. It is a very simple operation. It is always half of this number, and then you take this number, you square it, and you write 9. Because x squared plus 6x plus 9 is the same as x plus 3 squared. But since I can't just randomly add a 9 to my problem, I'm also going to put a 9 on the other side. And see how I kept my two sides equal by adding it to both sides? Now, if you have a number in front of your y squared, then you must factor first. So I'm going to write this as 4, this is the hard part, of y squared minus 2y plus blank. That 4 is going to affect the whole trinomial, every single part of it. Now you just leave it on the outside and you do what you were going to do before. You take half of this number, which is negative 1. You square the negative 1 and put it right here. So it's always the same process. And sure enough, y minus 2y plus 1 is the same as y minus 1 times y minus 1. But you do not add a 1 to the other side, because if you remultiply this, 4 times y squared is 4y squared. 4 times negative 2y is negative 8y. And 4 times 1 is 4. Because this 1 is affected by the 4 that's on the outside, you've actually added 4 to this problem. And so this side ends up being 4 because the two 9s cancel. And I'm going to just rewrite this one more time. Don't be lazy. Have every step look correct. So even though this one I could do in one step, I still wrote it at every point. This one took 3 steps. Don't try and skip steps. This is hard stuff. Now for the ellipse, the equation needs to be equal to 1. So your final step is always going to be make the equation equal to 1. And you do not do that by subtracting, you do that by dividing, because you don't want a random minus 1. Think about how the formula looks. It's just x over something, y over something is equal to 1. There's no plus or minus there. So you're always going to get that by dividing. So now, final answer, x plus 3 squared over 4 plus y minus 1 squared over 1 is equal to 1. Now that it's in this form, you did the hard work. The easy work is now you can find the center, which is going to be negative 3, 1, negative 3, 1. And I see a 4 under the x, which is 2 squared, so it's going to move in 2 in the x direction. I see a 1 under the y, which is 1 squared, so I move 1 in the y direction. Notice I've avoided the a's and the b's and all that kind of stuff. I just care about if the number is under the x, that's how much you move in the x direction after you take the square root. They didn't ask us for foci or anything this time, so we don't have to do that. You can practice it if you want to. If you need that extra work, the foci are at negative 3 plus the square root of 3, comma 1, and negative 3 minus the square root of 3, comma 1. So if you want to practice finding that, you certainly can. Number 4. Now this is exactly what we just did. So if you'd like to take that opportunity to try this one on your own, I would love that. But of course I will do it for you. So my first step is always to group all the x's together. I'm going to put a blank there. Then I'm going to group all my y's together. Y squared plus 4y. I always put a blank in there so I can complete the square. And I always move any extra things, in this case the 8, to the other side. We'll do the easy one first. So to complete the square, you always take half of this number, and then you square it, and you write the answer there. I always think of it as divide by 2, and then look, if you put that little square there, then it's kind of obvious. 2 squared is 4. And of course, I have to add the 4 to the other side. Remember that this one's a little harder. You cannot complete the square with the 4 there. So we're going to take that 4 out, and now I can complete the square. So I get x squared minus 2x plus something. It's going to be, take this number, divide it in half, and then square this. -1 squared is 1. But if I remultiply this, I'd get 4x squared minus 8x plus 4. So I've actually added a 4 to both sides of the equation. So now I have 4 times x minus 1 squared plus y plus 2 squared is equal to 16. Remember that your final step is to make it equal to 1. So I divide through by 16, and I get x minus 1 over 4 plus y plus 2 squared over 16 is equal to 1. So you can call them A and B if it's easier for you, but I just look to myself and say, I'm going to put 4 in the y direction and 2 in the x direction. So first I need to find my center. My center is at 1, -2. So if you're labeling things, center 1, -2. And like I said, you move 4 in the y direction, 1, 2, 3, 4. So there's my first vertices. That is 1, -6. And then 4 in this direction, 1, 2, 3, 4. So the other one is going to be 1, 2. And in the x direction, I'm only going to move 2. And I love these because now you can go ahead and draw your ellipse. Very easy to draw. Wow, that's really not that great. And it does ask for the focus points. So I'm going to do that by doing c squared is equal to a squared minus b squared. Now, I got through this whole problem without knowing which one was a and b. And I still don't need to know. Bigger minus smaller. That'll work. C squared is equal to 12. C is equal to the square root of 12, plus or minus, which is, breaking it down into parts you can do and parts you can't, is 2 square roots of 3. So I need to move on the major axis 2 square roots of 3 away. So going back to the square root of 12, the square root of 9 is 3. The square root of 16 is 4. So the square root of 12 must be somewhere in the middle. So I'm going to move 3.5. 1, 2, 3.5. You move 3.4, I'm not going to be able to tell the difference, right? Just somewhere between 3 and 4 is fine. And that point, though, now that you've drawn it, should be easy to find. Its x value is still 1, but its y was -2 plus 2 square roots of 3, and then -2 minus 2 square roots of 3. That's how you can do that. All right, we still have one more that we can practice on. If you still haven't done one on your own, I highly recommend it. But of course, I am going to do it for you. 16x squared minus 32x plus blank. For the y's, 25y squared plus 50y plus blank is equal to 359. With the blue one, I factor out the 16, x squared minus 2x plus blank. And now I have 16 times, I cut this in half, I square it and write that number here. But because it's being distributed, the 16 to the 1 also. This is actually a 16 that you're adding to both sides of the problem. I factor out the 25 and I get y squared and 2y again plus something. And I cut this in half. I write my square. 1 squared is 1, but I'm actually adding a 25 to both sides of the problem, which I think, honestly, you'll see if your work is neat and tidy. So this is equal to 400, which when I divide, remember your final step is to divide to make it equal to 1. When I divide by 400, my final answer is x minus 1 squared over 25. So 16 and 400 reduced to 1 over 25. And these numbers they try and make them work really nicely for you. 25 over 400 is 16. So it's not that these two just reversed. Please don't think that I just put the 16 down under here. I didn't. It's just that to give you guys nice numbers, sometimes this is the easiest way. So my center, it doesn't ask me to label all these points this time. I'm just going to draw it. But my center is at positive 1, negative 1. I'm going to move 5 in the x direction. 1, 2, 3, 4, 5. I'm going to move 4 in the y direction. 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4, 5. I didn't do my other x. Okay, a little hard to draw, right? Because it's almost circular. Not quite. It is a little bit squished, right? So there's actually a name for that squishiness. How this one just feels like it's a circle that's been flattened a little, where this one definitely feels like an ellipse. This one feels very elongated, and this one looks like an ellipse. The name for that amount of elongation is called eccentricity. It's the ratio of C to A. If the ratio is small, the ellipse is nearly circular. So I'm going to expect this one to have an E that is small. If the ratio is close to 1, then I'm going to expect the ellipse to be elongated. So I would expect this E to be closer to 1 than whatever I get for the last one. So we're going to go back now and find the eccentricity, which is a little frustrating because we didn't actually have to find C for this one. So we are going to have to take it and find it. C squared is the bigger one minus the smaller one. C squared is equal to 9. C is equal to 3. So the eccentricity for this one, E is very simply C over A, which in our case is 5, which is 0.6. Okay. So the ratio is smaller, then it's going to be closer to, it's nearly circular. Let's go and do another one. This eccentricity is, let's see, eccentricity is C over A, where's my C? Square root of 12 over my A, which is 4, and the square root of 12, getting my calculator out, divided by 4 is, thanks for waiting, 0.866. That is definitely a lot closer to 1, right? Which makes a lot of sense. And then the last one is eccentricity. Again, I'm expecting it to be closer to 1. And C over A. Ooh, luckily I had already written it down, right? So our foci must have been the square root of 3. And our A in this case is 2. So square root of 3 over 2 is 0.866 again. That was what we just got in the last one, I think. So 0.866, or almost 0.9. So definitely closer to 1, which makes sense because of how elongated it is. Okay, that is it for eccentricity. Oh, actually, there's a little challenge problem here. Find the equation of the ellipse with vertices 0 and plus or minus 8 if it has an eccentricity of 1/2. So I'm going to go ahead and write this answer, and hopefully you can figure that out on your own. It's a little bit more like a puzzle. But of course, I am going to do it for you. So personally, I would just make the roughest of sketches. So I just sit there and say, okay, 0, 8, 0, -8. So now I know that if these are the vertices, this is also the major axis, which means this is A. So A is 8. It's the bigger one. And if E is C over A, and E is 1/2, and A is 8, C must be 4. So now I know that the foci is at 4. Also, I know it's not elongated like this, right? It's going to be much more circular because the eccentricity is pretty low. It's only 1/2, which makes a lot of sense now that I see where that focus point fell. It's at 4. So what is missing from my equation? Just the b. So again, c squared is equal to a squared minus b squared. C squared, we just found out, 16 is equal to 64 minus b squared. B squared is equal to 48. I don't need to find the square root because b squared is what you actually will put into the equation. So I sketched it so I could have an idea of which direction it was going into, and that the 64 went underneath the y and not underneath the x. So it wasn't too bad. Hopefully you tried it. All right, we got a couple word problems here. So a portion of the White House lawn is actually called the ellipse. It is 1,060 feet long and 890 feet wide. So this is going to be 1060, and in this direction, it's going to be 890. So these two numbers are actually not really that helpful to me. I really want them in half. So 530 and 530, and then 890, if we cut it in half, is going to be 445 and 445. No reason to complicate things. We'll just leave the center at 0, 0. So all we have to do to write the equation, x is minus 0. We're going to put it right at 0. And in the x direction, 530 squared. And in the y direction, 445 squared is equal to 1. So I got to tell you, there's really no reason why we don't think that the lawn goes like that, right? It could be in the other direction. So it doesn't actually matter which way you have those two. But that would be an equation for the ellipse that is in the White House lawn. Okay, my favorite problem. Sanctuary Hall is an elliptical room in the United States Capitol in Washington, D.C. The room is also called the Whispering Gallery because a person standing at one focus of the room can hear even a whisper spoken by a person standing at the other focus. This occurs because any sound that is emitted from one focus of an ellipse will reflect off the side and then go to the other focus. Isn't that cool? I haven't actually done this in DC, but I did get to do one at a museum in San Francisco. And I have to say, it was really, really cool. It was called the Exploratorium, if you're ever in San Francisco. And literally, I'm in a museum full of people, and I'm standing here, and my 10-year-old kid could hear me talking quietly all the way from over there in this huge, huge museum. So anyway, it's very cool if you ever get a chance to go to DC and try this. So Sanctuary Hall is 46 feet wide and 97 feet long. So like last time, I actually really want half of those numbers. So half of 46 is 23 in this direction, and then half of this is 48.5. So now, how do I write an equation for it? x squared over 48.5 squared plus y squared over 23 squared is equal to 1. So there's an equation that models the shape of the room. How far apart are the two foci? So how far apart are people standing? So we need to find the foci. We have an equation for that. C squared is equal to a squared, so the bigger one, 48.5 squared minus b squared. That is, if you get out your calculator, you're not going to get out your calculator. You're going to wait for me to do it. I know this. And so C ends up being about 42.7. But keep in mind, that's only the distance from, C is always the distance from the center to the foci. So 42.7 right there, which means how far apart are they? You have to double it. So they are 85.4 feet apart. That's really far. So a football field is 100 yards, which is 300 feet, just to give you a sense of it. So 85 feet. All right, there's one more. It does say challenge. We're still going to do it, but I recognize that it's a little bit harder. Pretty much the word challenge means I'm not going to give you something quite this difficult on a quiz or a test. But if we were in school, we'd still be doing it in class. Also, I want you to know that the planets actually have elliptical orbits. So people that study planets and stars and things definitely have to know about ellipses. What that means is that if I were to draw the center of the ellipse for Mercury, the sun would actually be right here. The center of the sun is a focus of the orbit. So this is what it looks like. Sometimes Mercury is close to the sun when it's right there on its orbit. It's only 46.04 million kilometers to the sun. But when it's as far away from the sun as it could possibly be, then it is 69.86. So now that I've drawn it, you can probably do it, but the challenge part is definitely making this drawing. So to get my equation, I'm going to add my 46.04 to my 69.86. And so the entire length of this is 115.9, which means that just this distance, which we're going to call A, is going to be 57.95. So if we're writing an equation right away in the x direction, 57.95 squared. Now here's the next tricky part. So now that I know that this distance is 57.95, it's also that on this side, 57.95, which means now I can find C. So 57.95 minus the 46.04 is 11.91. And now that I have C, very long problem, I can use that to find this distance, B, which I need to do my equation. So C squared is equal to A squared minus B squared. So 11.91 squared is equal to A squared, 57.95 squared minus B squared. And your B squared should come out to be 56.7 squared. Like I said, I want you to see this problem, that how they get more complicated. And also I really want to talk about the fact that our orbits are elliptical. So the sun is not actually the center. Sometimes we're further from the sun and sometimes we're really close from the sun beyond just obviously the other points in the orbit. But I will not give you one this challenging on your quiz. So that is it for section 10.3. Have a great day.